Good morning, everyone. I'm very grateful for getting the opportunity to participate in this program, and I'd like to thank everyone for attending today, specifically Angeli Adams, Angeli Day, and Susan Oates. They have been working with me for the last 2 months. This is they have been spending a lot of their time to develop myself. So I'm very grateful to them and everybody. My name is Syed Islam. I'm a staff scientist at the ORNL National Lab. I'm a chemical engineer by training, and I've been here about 6 years. And my research focus is developing new materials, new processes for clean energy applications. I've been working in here about in 3 different areas. One is critical material separation, such as rare earth battery materials from end-of-life cell phone, electric vehicles. Another area I've been working on carbon capture, separation, and another area I've been working on is bio-separation for sustainable aviation fuel. In the last 6 years, I'm very happy that within 6 years I have developed 3 distinct separate technologies or co-invented that are licensed to 3 different independent companies for commercialization. And some of the companies has spent almost $50 million to the technology that I have developed here with all of your support. Today, I'll be talking about a green capture, carbon dioxide capture using a hollow fiber membrane contactor-based process using a green solvent. And I hope that this technology one day will also hit the market. So in CO2 capture, it's a very well-known phenomenon that it is causing the global warming. Some of the major source of CO2 emission is steel industries, iron industries. They use blast furnace, they use thousands of degrees Celsius temperature, getting the coal burn to produce or emit CO2. We get the electricity burning coal-fired power plant in TVA next to us, but those are the major source of CO2 what we do not feel. We stay in the AC, but when we get to outside, we feel warm. But because these ACs or electricity is produced by burning coal that generate CO2. And I am one of the poorest country in the world, Bangladesh, where most of my time I spent in raising cows and goats. I used to grow rice and paddies, but because of the global warming, my all rice and paddies used to get out of my field because of the flooding. That one of the pictures shows there. So I'm very excited about the technology I've been developing. But the current state of the art technology is called amine-based processes that can separate CO2. But that current amine-based processes requires high energy because it can absorb the CO2, but to dissolve the CO2 or regenerate the solvent requires very high temperature, 130 degrees Celsius temperature. And during this heating regeneration process, it degrades, though there is a lot of solvent loss and high operating cost. To address this challenge, I've been working here to develop a highly scalable hollow fiber membrane contactor-based process to capture CO2 using a green solvent. Thousands of hollow fiber membrane contactor can be put together into a small module. And it is a nanoporous material. This is a small blowout of a fiber. And in this fiber, the solvent can go inside the fibers. And outside the fibers, the flue gas, which contains mostly CO2, nitrogen, and oxygen, through these nanopores, CO2 and all gas can come in contact with the solvent, but the solvent can selectively absorb CO2, but it doesn't absorb nitrogen. Once it comes out of the module, it releases the CO2, and it continuously the pump continuously pumps the liquid through the module. So it is a single step process. There is no regeneration happens because inside the module it is under pressure, but once it comes out of the module, it is atmospheric pressure. Atmospheric pressure, it releases the CO2. So there is not essentially any regeneration steps. It continuously running the device and continuously separating the CO2. The membranes are commercially available. Those are widely used in desalination industries, degasification industries. The precursor of the solvents are also commercially available. So we have demonstrated the concept in a laboratory scale using a mixture of nitrogen and CO2, which are the major components of the flue gas. And we found that the CO2 purity recovered from the flue gas is about 97%, which is, it is according to DOE, some of those above 95% is good enough. And the solvent is green solvent. It is made from natural ingredients, so it's environmentally sustainable as opposed to the amine-based toxic when it degrades. And it is a single step process. DP2 solvents or the green solvent, they're mixed together ingredient. There is no post separation. So it's very simple synthesis. It requires low energy because it doesn't require heating to regenerate the solvent. So low energy, and it's a continuous process. This process is adsorption happens, equilibrium reach, it goes to another stage for regeneration. But in our case, it's not equilibrium limited, it's a continuous process. We have this process, this project has been supported by LDRD, ORNL LDRD last 3 years. Recently, it's been selected for DOE Energy ICOR, funded by Office of Fossil Energy and Carbon Management, that will be participating this fall. We have a provisional patent application. We have published a couple of papers. One of the paper is Industrial Engineering and Chemistry Research, and this paper is also featured in the journal cover page. And here, the process showed great results in a simulated flue gas, but it needs to be evaluated in a real-life flue gas. And the performance can be further enhanced by process parameter optimization and functionalization. And the separation is only one part, but from cradle to grave, we need to do the techno-economic analysis and life cycle assessment to see its complete techno-economic analysis and economic viability, and demonstrate in a larger scale. Although we know that hollow fiber membrane contactor-based is scalable, it's widely been used in other industries, but it needs to be demonstrated for that particular industry. And we'll be looking for partnering with industries, specifically the CO2 emission industries such as TVA or steel industries, so that we can use their feedstock to evaluate our processes. And for membranes, with a membrane company, or the solvent chemical industries partnership. And we have a provisional patent application, it can be licensed. Thank you.